Okay, so we're going to start with the first learning target, 1.1. I can identify rational and irrational numbers. And to begin, our overall numbers, we can title that we have real numbers. Okay, and then these are broken down into two categories. So the first category we're going to talk about are our rational numbers. Okay, and rational numbers are numbers that you have used probably most of your life, and maybe you just didn't know that they're called rational numbers. Rational numbers are any number that can be written as a fraction. Okay, and we're going to go over some examples of all those. Whole numbers can be written as a fraction. You can take any whole number and put it over 1. So whole numbers are an example of rational numbers. Since it can be written as a fraction, fractions we also write as decimals. Now there are some things about the decimals that we have to be careful of. To make it rational, the decimals can terminate. And if something terminates, that means it ends, it stops, it's done. So the decimals can terminate or they can repeat. Okay. So let's list out some examples of some numbers that would fall under our rational category here. Okay, we started with whole numbers, like the whole number 3. 3 is rational. We can write that as a fraction. Any whole number we can put over 1. Negative numbers as well. Integers fall under rational numbers. I can take negative 7, make it negative 7 over 1. Okay. Our fraction, 75 hundredths. Okay, that terminates, that's a terminating decimal. It stops, it ends. This can also be written as a fraction, 3/4. So the decimal terminates, I can also write it as a fraction. It's rational. And as far as other decimals, a repeating decimal, you might sometimes see the bar over it. 3/10 repeating is our 1/3. Okay, so repeating decimals also fall under rational. Mixed numbers are okay. That's a fraction. That's still rational. And your improper fractions also fall under here as well. Okay, one other thing we have to talk about, because we're going to run into it on the irrational side, are our square roots. So like if you see this symbol here, that's asking you the square root of 16. So what number can you take and multiply by itself to get 16? And 4, because I can do 4 times 4 and get 16. Well, this answer comes out to a whole number, 4, and I can write that as a fraction. So when this is simplified, it shows me that that would be a rational number. Okay, same thing, square root of 25. What number do we multiply by itself to get 25? 5 would be the answer. Okay? And you guys have on your calculators that option, the square root, is up above the x squared button here. And so to get to that, you have to do Control and then x squared. And that will bring it on your screen there for you. Okay, there is one other type, and if we do the same symbol, but now put that little 3 in the front, that changes it from a square root. Now it's asking for the cube root. So let's say we want to know the cube root of 27. What number can we now take and multiply by itself 3 times to get 27? And that would be 3, because 3 times 3 times 3 gives us 27. Okay. The cube root feature is also on your calculators. So if you get a really large number and you're not quite sure, that cube root is next to where the square root is. Okay, again, it's up above in yellow, so you're going to have to hit Control and then the up arrow there. So you can put that in, cube root of 27, into your calculator, and it would also give you 3. Okay, I just wanted to introduce those to you because we're going to run into our square roots and cube roots on the other side also when we talk about irrational numbers. So let's move over here and talk about our other side of the real numbers, and that is irrational numbers. Okay, irrational numbers cannot be written as a fraction. And then some crazy things happen with their decimals. Their decimal are infinite, and I like to think that word sounds like infinity. So the decimals are infinite. They go on forever. And the decimals are also non-repeating. So there will just be random numbers. You won't see that repeating pattern in the decimal. All right, some examples, and you guys already knew one of them. An example of an irrational number was pi. Pi is one of those crazy numbers. We don't have a fraction to represent pi. And if we approximate, usually we just round or say pi is 3.14. But really, pi is 3.14159, and it's going to keep going for pages and pages if we could list it out. Okay, random numbers, no pattern, and it is infinite. Okay, the other way that we run into irrational numbers are sometimes when we take the square and the square root and the cube root. So if we're taking the square root of a number that's not a perfect square, so think of like 2. Is there any number you can multiply together by itself to get 2? And if you try that out on your calculator, you'll notice it's going to give you a long decimal. Whoops, 1.41421. Now the calculator does stop because it ends up rounding it and cutting it off. It can't fit this whole number. But if it's coming out to a decimal, this decimal continues on. It is infinite. So you need to know that if you're getting a decimal when you do the square root on the calculator, that it falls irrational. It goes on. It's non-repeating, and it goes on forever. Okay, same thing with the square root of 3. There's no number that you could multiply by itself to get 3. Okay, on the calculator, it comes out to 1.73205. Again, it stops it on the calculator, but we need to know that it really goes on. It is infinite. No repeating pattern, infinite, falls under irrational. Okay? So, when you do square roots, if they come out as a whole number on your calculator, when you're taking the square root of a perfect square number, and it comes out to a whole number, that's going to fall under rational. If you're getting a decimal, you need to know the decimal goes on, it is infinite, and it is an irrational number. Okay, just like square roots, this can also happen if we tried to do the cube root, let's say, of 10. Okay, what number could you multiply by itself 3 times to get 10? There isn't one. When you try it on your calculator, it comes out to about 2.15443. Random numbers. And again, this one's going to go on. It is infinite. Okay, so this one here, cube root of 27, that's a perfect cube number. It comes out to a nice whole number, and it falls under our rational side. But sometimes when we take the cube root, if we get that long decimal, we need to know that it's going to be infinite, no repeating pattern, and we'll have a rational number. Okay, you also have this chart that you can put in your notebooks. And I just like how this kind of breaks it down as well. Your rational numbers, your decimal that terminates, decimals that repeat. Integers fall under rational numbers, and also your whole numbers. Notice zeros on there as well. Okay, and then you just have a couple more examples of irrational numbers over here. Okay, these go on, they're infinite, and then there's no repeating pattern in them.